Okay, 7th grade. We are in Chapter 8, Section 7, Quadrilaterals and their areas. Quadrilaterals. We're moving away from triangles to quadrilaterals. What makes a figure a quadrilateral? Tyler. It has 4 sides. Yay, a 4-sided figure. So we can draw one. Here's one. Right? Ooh, that's taking up a lot of space. That's interesting. There's a big old quadrilateral. I think I'm going to erase that one because it was just too big. Let me see if I can make it smaller. There we go. There's a quadrilateral. This quadrilateral looks like what figure, George?
Square.
A square, or it could be a rectangle. On the board it looks like a square. On my computer it looks to me more like a rectangle. So it just depends on the scale that you're looking at. You're right. And if we add up all 4 angles in a quadrilateral, they always add to the same sum. Can any of you tell me how many degrees would be inside of a quadrilateral? I mean, if this is a quadrilateral and it's a square or a rectangle, right? And so what is every corner? 90 degrees. So we basically have 4 times 90. And what would 4 times 90 be? So the sum of the angles is 360 in every quadrilateral. Okay? We will classify quadrilaterals. Okay? The first type of quadrilateral is one that has 2 pairs of parallel sides. So the one we just drew up here has that, 2 pairs of parallel sides. Sometimes they look more like this red figure here. This also has 2 pairs of parallel sides. So we would call these kinds of quadrilaterals what? It begins with a P. Good job, parallelogram. 2 pairs of parallel sides. And we show that the sides are parallel using these little arrows. So the 2 sides that have 1 arrow are parallel, and the 2 sides that have 2 arrows are also parallel. So the whole thing is a parallelogram. So the next type of quadrilateral is a parallelogram that has right angles. So what do we call all parallelograms that have 4 right angles?
Square.
A square is one, but a square is more specific. Can you tell me, what about if 2 sides were longer and 2 sides were shorter? What would we call that? Instead of a square, it's a, begins with R. Rectangle, good. So a rectangle is a parallelogram that has 4 right angles. And then there's a more particular type of parallelogram that has 4 right angles and all the 4 sides are the same length. So Ronnie, what's that called?
Square.
A square. That's the more particular. Oops, I'm not on square yet. I'm actually on rhombus. So before we go to square, can you tell me what a rhombus is?
It's like square.
It's like a square. But what's interesting about a rhombus is all 4 sides are equal, congruent. The angles don't have to all be congruent though. Okay? So in a square, the angles and the sides are congruent. And so it's the most particular type of parallelogram. We can actually call a square a regular rectangle. Regular means all sides are the same. So probably the least used word among all of these is which one? Which one do we use the least? Actually, I think we use rectangle a lot. Rhombus. I think rhombus is the one that is least used. Like when you're in preschool, they don't usually say, let's cut out a rhombus, right? But they will do squares, right? Squares and rectangles. So we really need to make sure we understand a rhombus. So tell me, how is a rhombus different from a square, Ronnie?
Because a square, because that one has 2 Two equal sides.
Four equal sides. A rhombus has four equal sides. So does a square. So how are they different?
It's wider.
It might be wide. So what makes it wider when you say that?
Because the
What doesn't have to be all the same in a rhombus?
their angles.
Angles, that's right. So the opposite angles are the same, but not all angles are necessarily the same. Okay? Good. And we have one final quadrilateral that I want to talk about. And this quadrilateral only has one pair of parallel sides. Do you know what that's called? Here's what it looks like. Good job, a trapezoid. It has exactly one pair and only one pair of parallel sides. Okay, so now I'm going to show you two figures, and you're going to tell me what type of quadrilateral they are. And I'm not going to ask you to draw them right now. So just you can put your pencil down for a moment, and don't say anything until everyone has had a chance to think. Okay, because once you say it, other people don't have to think, and I want you all to think. So you're going to tell me what type of quadrilateral number one is. 3, 2, 1.
Trapezoid.
Trapezoid, good. So why is it a trapezoid, Tyler? Okay, so the two sides that are parallel, he says, are parallel and yet they're not the same length. Okay, so we have exactly one pair of parallel sides. Okay, and I'm going to count you down here, so don't say anything. And the most specific type of quadrilateral is what you're going for here. So the answer is 3, 2, 1.
Parallelogram.
You got to be more specific. It's a rhombus. And how do you know it's a rhombus, George?
Because four sides are like parallel, but they're not the same.
Four sides are parallel, and these little dashes say that all four sides are
Equal.
the same length, which is true for rhombus, right?
Mhm.
But notice that these two angles are big obtuse angles, and then these two angles that are across from each other are acute. Okay, so they are different angles. So let's find an unknown angle measure in a quadrilateral. So pause the video, take it down, see if you can answer this question, and come back and check. Okay, so how might a person figure this out, Ronnie?
Maybe they would use the same that.
I don't think you need the Pythagorean theorem. Actually, you just need to know about quadrilaterals. What do we know about all these angles in a
it's
quadrilateral?
360 degrees.
Very good. They all add up to 360. So we can actually write 360 equals, what would you say?
Equals 85 plus 95 and plus 40.
And wait a minute, there should be 4 angles in this quadrilateral.
Plus 0?
Plus what?
X.
Plus x, the unknown angle.
Mhm.
Okay? This is how we can find the unknown angle. So let's start adding up what we do know. And 85 plus 95. Do you see if I take this 5 away from the 95 and put it over here? It's like I have two 90s, right?
Yep.
What did two 90s add up to?
180.
180. And then I'm adding 40. Can anyone do that in your head? 180 plus 40?
It's
180 plus
220.
220. Good. So we have 220 plus x. Okay? And now, Tyler, how do we get x isolated? Subtract, good. Subtract 220 from both sides. So we get x alone. And x equals, you want to tell us, Tyler, what x equals? So when we subtract, we know that this missing angle is 140 degrees. Does that seem reasonable?
Yes.
Does this angle look bigger than a 90-degree angle?
Yes.
So we always want to check to make sure it's reasonable. Okay, so if you're asked to find an unknown angle measure, use what you know about quadrilaterals. We have 360 degrees in a quadrilateral. Okay, today we're going to find the area of a parallelogram. And we've already found areas of triangles. So parallelograms are probably the very first figure that most students learn to find the area for, right? And who knows the area? Raise your hand if you know the area of like a rectangle, which is a parallelogram, right? Can you say it? A equals base.
Base times height divided by 2?
No,
Base times
just
height
base.
divided by 2 is a triangle, right? But
Yeah.
just base times height, right? Now sometimes, because some parallelograms are rectangles, people say area equals length times width, right? And length and width are synonyms for base and height. Remember, height in geometry is always perpendicular. So you need to make sure height is a right angle to the base. Okay? Okay, we're going to find the area of 2 parallelograms. So here's the first, and so jot it down quick. Little image. We've got a lot of numbers here. And what do we always begin with when we're finding area of figures?
Base times height.
Which is called the
The formula.
formula. So you always begin, that's your map. You know, that's where you're headed here. We're finding area. And area is what we don't know, so it remains a variable. It's the unknown. And so now who can tell me the base of this figure? You have to look for one complete side, right, Ronnie?
5.
5, good. So we have 5 units down here, and that looks like a base. And we have this dash line here, and then we have a side that's 3. So which of these two would be our height?
2.2.
2.2, that's right. Because 2.2 is perpendicular. We see that here.
Yeah.
2.2 is perpendicular to our base. So we would multiply by 2.2.
So
Now,
does
what might a 5th grader do here? They might multiply by what?
3.
3. They just take 2 sides and start multiplying, right? And we can't do that because this side that has 3 over here is not perpendicular to the base that we chose, okay? So now we simply, I don't see any units here, so sometimes we just put a little u. Like, I don't know what they're measuring in here. Maybe it's inches, maybe it's centimeters, I don't know. So we'll just call it u. So what is 5 times 2.2?
Oh, 11.
11. So we have 11 units squared. Whatever they are, they're squared now. Okay? Good. Okay, last one. Try this. Find the area and the perimeter. And then we're done. Let's start your assignment. Okay, we can start with finding the area. Again, area equals base times height. We're looking for a perpendicular height. So we can fill in our known information. It looks like we have a base of 10 centimeters and a height of 4 centimeters. And so when we multiply these together, we end up with an area of 40 centimeters squared. Now to find the perimeter, we take a walk around the figure, right? So you can choose any vertex, start there, and as we walk, we travel 10 centimeters. We're walking to the right here. And then we walk up and we travel 5.6 centimeters. And then we walk across the top, which is another 10 centimeters. And back down, which is another 5.6. Okay, when we add this together, we have 15.6 centimeters times, or plus another 15.6 centimeters. So it looks like we have 31.2 centimeters as a walk around, as a perimeter of the figure. There you go. Have fun. Work hard.